Okay, now we've looked at graphing quadratic inequalities and graphing systems of inequalities. We're going to look at solving quadratic inequalities algebraically right now. Now, what this means is if this was an equal sign right here, so if this was our quadratic equation, you guys have learned numerous methods how to solve this. When it's an equal sign, you are looking for the exact values that make this statement true. So you're looking for the exact values that you can plug in for x and make this a true statement. Now, when you have an inequality sign, so a less than or greater than, you're looking for a range of numbers. Okay, in this case, we're looking for all the values of x that would make this trinomial less than 0. So we're not going to have just one or two numbers as an answer. We're going to have a range of numbers. Our answer is always, it's going to look like an inequality, like x is less than a number or x is greater than a number. So there's some specific steps to go through to solve this. So what I want to do is I want to go through these steps with you so you can see. So make sure you're writing down the notes along this whole process because you want to follow these steps every single time. So the first thing that you want to do, we need to figure out our critical points. Okay, that's a new vocabulary, our critical values. Our critical values are going to be the values that make this quadratic equal to 0. Okay, so that's the first step here, is to rewrite your quadratic with all of the terms on one side, so in standard form, and replace the inequality with an equal sign. Okay, so first step is to write your quadratic in standard form and replace the inequality with an equal sign. So here we've got x squared minus 3x minus 4 equals 0. Next, we want to find the critical values. So we want to know what values for x make this equal to 0. So here you can use whatever method you want to solve this. Sometimes it might be factoring or quadratic formula, completing the square. Use one of the methods that you've learned so far to find the critical values. In this case, we can factor it. This just ends up being x minus 4 and then x plus 1. Okay, x minus 4 and x plus 1. Okay, so right now we've factored that and we've got it equal to 0. Now, our critical values are the ones that make it equal to 0. So remember, we have to set each of these inequalities equal to 0 and solve in order to get our critical values. So we have x minus 4 equals 0 and x plus 1 equals 0. And if we go ahead, if we add 4 to both sides, we get x equals 4. And here we subtract 1, we get x equals negative 1. So these are our critical values right here, or I'm going to call them CVs for short. Sorry, that looks like an N. CV, critical values. Now, we're going to use a number line to help keep track of this, because again, we're trying to find a range of numbers. So these critical values are going to tell us the key points on the number line that we need to check. Okay, so here I'm going to put 4, I'm going to put 0 just so you can see, I'm going to put negative 1 right here. And inside here is 1, 2, and 3. And there's above 4 and less than negative 1. Okay, so right now these are the critical values. Now we need to look at our original inequality sign. Okay, less than or greater than, or less than or equal to, greater than or equal to. So since this is just a less than and there's not an equal to, we're going to put an open circle on our critical values. Now remember back to Algebra 1 when you solved inequalities like this. An open circle means that this value is not part of the solution set. Okay? Because we cannot have this equality equal to 0, it's just less than 0. These values are not part of our solution set. If this was a less than and equal to, or a greater than or equal to, then we would make these shaded in, and these numbers would be part of our solution set. So this is just like when you're figuring out if it's a dotted line or a straight line. Because there's no equal bar on the bottom, these are open circles on your critical values. Okay, now what we need to do, we have just split our number line into 3 separate parts. Okay, we've got one part right here, one part that is less than -1, we've got one part that is between -1 and 4, and another part that is greater than 4. So what we want to do right here is we want to test our 3 spaces. So what I'm going to do is I'm going to go back and make it a little neater right here. So right here, this is what we've got so far. Okay, we've got our number lines with open circles. So in order to test our 3 spots, what you want to do is pick a value from each region, and you want to plug it in to your inequality. Okay, and what will happen is, if by plugging that value in, if it makes a true statement, then you know that that region is part of your solution. If it makes a false statement, then that region is not part of your solution. So let's look right here. Let's go ahead and test -2. Okay, we're going to test x equals -2. So let's go ahead and plug it into our original equation right here. So we're going to plug in, we've got -2 squared minus 3 times -2 minus 4. So that's 4 plus 6 is 10, minus 4, that's 6. Well, 6 is not less than 0. That's what this is showing right here. That when we plug -2 into our original equation, it is not less than 0. So this region is not part of our solution set. Let's go ahead and test the middle region right now. Now again, we're just picking one value from here. You could pick any of these numbers. You could pick 1, 2, or 3, or -3. You just need to pick one value from that critical region. So let's pick 0 now. Okay, so now we're going to plug 0 into our original equation. So we get 0 squared minus 3 times 0 minus 4. That gives us -4. So we get -4 is less than 0. That's a true statement right there. -4 is less than 0. So this region checks out. We know that our middle region is part of our solution set. For the last region, we're just picking 5. And again, we could pick 6, or we could pick any number greater than 4. We happen to choose 5. So let's go ahead, we're going to plug 5 in to our original equation. So 5 squared minus 3 times 5 minus 4. We get 25 minus 15 is 10. Minus 4 is 6. So again, let's check 6 less than 0. That is a false statement. So we know that that region is not part of our solution set. So what we've done with our critical values, we use it to split up our number line into regions so that we can check to see which regions are part of our solution. So here we know that just our middle interval is. So in order to write out the answer to this, we got -1. So we know that x has to be greater than -1. And then we have 4. We know that x has to be less than 4. Okay, so we know that x is greater than -1 and x has to be less than 4. So we can write this as x is in between -1 and 4. So this right here would be the solution. We know that, again, x is greater than -1 and less than 4. And notice there's no or equal to here because our original problem just had a greater than sign or less than sign. Okay? So remember your steps again. First thing you want to do is replace the inequality with an equal sign, put it in standard form, factor to find your critical values, or solve, whichever method using quadratic formula. So once you get your critical values, you create your number line, and then you pick a number from each interval or region and then plug it into your original equation and see if it makes a true statement. If it does, then it's part of your solution set, and if it doesn't, then it's not part. So this one just so happened that our solution set was the region in between our critical values. Sometimes you'll find that the solution is, the regions outside of your critical values, or just one region. So it's different every time. So you always have to go through and check all 3 regions. All right. So what I'm going to do right now is I'm going to go ahead and put up a couple questions here, and what I want you to do is answer the questions that pop up right now.